Hello everyone, this is Amritpal Singh. Welcome to the next video. In my previous video, I've just shown you how we can implement the logistic regression in R Studio in R language. In this video, I'm going to discuss what is the meaning of KNN algorithm. So KNN is a stand for K nearest neighbor, right? In this video, I'm just be giving you some short description about this algorithm, and the next video will be based upon the implementation part. So let's get started. So if we talk about the KNN, so as I've already told you, the KNN is nothing but stands for K nearest neighbor. Algorithm is a supervised machine learning method employed to tackle the classification and regression problems. It means it's used for both classification and regression, and the supervised meaning is it's working under the supervisor, right? Like we have in our schools that teachers teach us, right? It's a supervisor to us. It tell us what to do. In the same way, it's a supervised algorithm which is working under the machine learning. And let's see how it works. So you can see in this diagram, I'm having this little graph available on the left side, right side, before KNN and after KNN. In this case, you can see we have a two category of data available, right? So now let's suppose we have a new data point coming up, and we need to decide that to which category it belongs to, okay, the red one or the green one. All right. So this is we have to discuss today, that what are the steps available so that we can end up like getting this result on the right side, that this data point belongs to the red category. So how it happens? Okay, we have a data set available in which we have a two category of data available. If a new data point coming in, and we need to decide that to which category it belongs to, the green one or red one. So we need to decide with the help of KNN algorithm that it is belonging to red one or green one. So let's see how it works, right? So what are the steps available? We have 4 steps available. First of all, we need to choose the number k of neighbors, means how much value we need to start with, like how much neighbor we want, 3, 2, 4, 5, right? You can decide this k value, right? Afterwards, take the k nearest neighbors of the new data point according to Euclidean distance. We all have studied mathematics in our school, right? We know that what's the meaning of Euclidean distance is one of the very simplest of the formula in which we try to find the distance between 2 points, like x2 minus x1 square plus y2 minus y1 square under root. So in the same formula we need to apply, and we need to find out who is the closest neighbors. Among these k neighbors, count the number of data points in each category, means in which category we have how many points are available, like 3 points, 2 points. I'll discuss all the points with the help of examples in upcoming slides, but in this case just remember that here we need to count the number of points in each category. Afterwards, we need to assign the new data point to category where you counted the most neighbors. Which means, let's suppose if category 1 has 3 neighbors and category 2 has 2 neighbors, it means I'll be placing the new data point to that category which has more neighbors, right? And at last your model will be ready. So what's the first step? The first step is to choose the number of neighbors, k equal to 5. Okay, we can simply find that, let's suppose by looking at this diagram, we can say that these 3 red points are closest and these 2 green points are again closest. It means we have a total 5 neighbors available. We have 5 neighbors to this new data point. Okay, this is the first step to choose the number k of neighbors. Next step, here we need to work on the formula. As I've already told you, we all have studied the mathematics, and this is the basic formula for finding distance between 2 points, where we have the coordinates available x1, y1 and x2, y2, and we have a simplest of formula available in mathematics, x2 minus x1 square plus y2 minus y1 square, then under root. Okay, this is the Euclidean distance between points p1 and p2. So now in the second step, we need to take the k equal to 5 nearest neighbors of new data point according to Euclidean distance. Maybe over there we were just looking at the diagram and then we were deciding, but with the help of k nearest neighbor or the Euclidean distance, we can able to find the nearest neighbor. So we have 3 here, 2 here, okay, as a step 2. Now among these k neighbors, as we have, you can see it is now showing in this red circle and the green circle. These are the neighbors of this new data point. Count the number of data points in each category, and we can easily find out that category 1 has 3 neighbors and category 2 has 2 neighbors which are closest to this data point. And we already have seen in the in the description which I shown you earlier, that the category which has more number of neighbors, that this data point will be belonging to that category. So in this case, category 1 has got 3 and category 2 has 2. It means we know who's the clear winner. The clear winner is category 1, right? So you can see in the step 4, assign the new data point to the category where you counted the most neighbors. Obviously this will be belonging to the red one, that's why it's turned out to be red. This is the simplest of algorithm available. That's why in the very first slide I have shown you it was red, and now we have decided, we have gone through the steps. Now we have concluded this is actually a red. Why? Because this category 1 has most number of neighbors available, because we have counted it, and this will be belonging to the category 1. right? So this sums up this whole video. I hope you must have understood the basic concept of the KNN algorithm of classification, that how it works. In next video I'll be discussing that how we can implement the same in our language. So thanks for watching guys, see you next video.